I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey Ben.
Hey Matt.
How you doing?
Good.
Glad to hear it. Well, I've been thinking a lot about the various programming languages that are available to us.
So many.
There are so many, and sometimes I stare at the Compiler Explorer drop-down of languages that the Compiler Explorer supports, and I don't even recognize a third of them because people add them in, and apparently there are languages like, I forgot now, there's things beginning with Z that I've never heard of before. Zig, that's the one I'm thinking of. Zig and other things, and there are so many out there, and it made me think, why do we have so many programming languages, and what causes people to choose a particular programming language over another?
In the future, everyone will have their own programming language made
it
just
feels
for
that
them.
way.
Yes.
It feels that way. It feels like, and in the world of, domain-specific languages, of some of which are subsets of other languages, we have got a little taste of everyone's got their own language. But why is that?
I mean, that's a good question. I was there was a period of time in my career. I've stopped doing this recently, but there was a period of time where I would try to learn a new programming language every year.
Right.
And I would always look for things that kind of would stretch the way that I think about problems. You can only use so many, C derivative programming languages before you start, recognizing the same patterns over and over again. It gets boring.
Well, I guess that's like point one is that programming languages differ more in just syntax. It's not just like, hey, this thing uses squiggly brackets, this one doesn't. This uses white space. There are some actual, real, deep differences in the way you think about programming and how that maps to the primitives that those languages make it easy for you to do.
Absolutely,
right?
Absolutely. Yeah, I mean, languages like Lisp and all the Lisp derivatives are sort of a very different way of thinking about programming, although you can model a lot of those same ideas in other languages that are not even close to Lisp. And, that was one of the reasons that I started doing that, is because I would find that I would be forced to use ideas if I wanted to, be in Rome and do what the Romans do when learning a new language.
Right.
And then I could take those ideas back to the languages that I was using in my day job in some form or fashion most of the time. And I feel like that maybe trailed off a little bit the more languages I learned, but certainly when I was doing it in the early days, it was very inspiring.
Right, in that way that learning a foreign spoken language or written language opens your mind to a different culture and the ideas that go with it, and there will be some of those words that, obviously everyone's got a word for dog and cat and things like that, but there may be some subtle things in a spoken language which you can't convey, that don't translate. You have to think about things in a different way.
Yeah.
And you get the same in programming languages too. As you said, like Lisp, I remember like one of the first things I did when I moved into the world of trading was pair with of somebody who was writing a ton of closure, and it was like a massive brain explosion for me because I'm such an imperative, one instruction after another, literally kind of a person, and then to see it done in a Lisp-like language was mind-blowing for me. And at first I disliked it greatly. It's like, it would be much easier to do it if we were to just write a normal program like normal people do. But then I realized, no, there's a lot to learn from this. And as I've developed as a programmer, I've realized that some of the more core ideas like immutability and things like that have come from languages like Lisp. I mean, obviously they're not unique to Lisp, but that way of thinking of like very, very functional mutability, that lack of mutability, pure functions and things like that. Now I use a lot in my day job as a C programmer, right?
I had that same experience doing a project in Haskell, which the project itself did not go great, but just being forced to use that language to do something. And this was actually at my actual real job.
And your real job, right? Not just a toy project.
No, this was for real. And so being sort of thrown into that environment and forced to learn it was good. It sort of made me think about a lot of different ideas I hadn't been exposed to before. So, yeah.
And that's without even going in. I mean, so far we've said Haskell and Lisps, which definitely are very different from like your C family or can't even think, what was the progenitor of C, beginning with A? Oh, can't think now, but like that suite of families that came together, that are very imperative, and you can pretty much read the code line by line and go, this is what's going to happen.
Mm-hmm.
And then you've got Lisps, which are still have that flavor to them. But then there are other languages which are very much like, and maybe if Haskell falls into this, I'm not as sure about it. But like there's a lot of pattern matching in Haskell I'm aware of.
Yeah.
And like if you think of things like Prolog, even, which is in a completely different way of a makefile is essentially a programming language of a sort,
Mm-hmm.
which makes you think about things the other way around. You're like, how do I achieve this? I don't know. I have rules that match, and the rules get me to my destination. And as long as there's a path from what I want and all the transformations that can be applied, then a solution is found and my program runs. Or that's a very different way of thinking about it than literally writing the code to do it yourself. So, but when one sits down and one's going to start a new project, it seems like, I mean, you said it yourself, like the way that you've learned these languages or other languages, like myself actually, is, you spend a bit of time once a year or every other year or something, and you go like, hey, this is the hot new programming language. Why shouldn't I try this out? And you try it and you learn, and that's great. And sometimes maybe you can then use that in your day job. But when you're sitting down to say, like, write a little program at work, how do you make a choice about which language to pick? What are the criterion? What do you think of when you're sitting down to write something?
Yeah. That's that can be a hugely impactful decision for any company. Getting that wrong can be very, very painful. The main thing that I think about is the community behind the language, and there isn't always a true sort of singular community. Some languages have tighter knit communities, and some of them have much broader committees that govern them.
Yep.
And it's sort of, you can run the gamut just like you can with language teachers and other things of like who are the people behind this language. But I think that one of the most important things to look at beyond syntax, beyond standard libraries, beyond even the user library community behind it, is the community behind the language itself and who's sort of driving it forward, because whatever they value, you will be forced to value.
Right.
If they value strict algebraic types, you will be forced to value strict algebraic types. If they value testing, you will be forced to value testing, and so on and so on and so on.
This is like when you pick a framework. If you find yourself not fitting in with the thought processes of that framework, you find you're going to be swimming upstream the whole time.
Mm-hmm.
Even more so with a language. It's like, well, I want to do, I've picked a language which is functional, and I'm trying to do imperative style programming. You're not going to get very far, right? You've made your life harder for no good reason. So
Yep. And as the language evolves, and some languages evolve faster than others, but as the language evolves, it will tend to evolve in a direction that meets the values of that community, right? So, you can sort of look to the future a little bit to see, like, okay, what are the new features of this language going to be? Well, let me go see, who are the people that are very active in this? What do they value? Right. Look at the conferences, look at the talks, look at the papers that are written, and try to figure out, like, what is important to them, right? Not necessarily what's in the language today, but like, what do they think is important?
What are the values of the drive? So that you're taking a very long-term view there, which is commendable, right? Especially as I gave you the question of like, hey, if you're sitting down at work,
right, exactly,
what should you be doing,
yes,
right? So that's obviously couched in that kind of the background. That shouldn't necessarily apply if you're writing your own project. If you're just going to sit down and write, like, bang out a command line tool, right? Mm-hmm. I mean, this is a perfect example of something that you would then use to learn a language, like every year or so, as you say. And of course, that takes time and spare time, and not everyone has the time to spend learning a whole other language. So we should definitely note that. But it is a fun thing to do. But then, do you have an instinct as to what would be the next language you learn? I've got my answer. What would be the next language you would sit down and write something out in if you were to start from scratch, apropos of nothing for yourself?
Assuming so, I would for those kinds of projects, I would definitely lean more toward like, what are the libraries available to me and what can I get done quickly? If I'm learning a language just to learn something new, I would actually go back to a language that I had already tried to learn and sort of used a decent amount already, which is Rust. I think Rust has come along a bit since I've used it last, and I think that it is a very interesting language, and I would want to use it again. I don't have a project in mind that Rust would be a good fit for right now. There was a period of time where I was following a guy on Twitter that was really heavily involved in embedded Rust.
Interesting. Yeah.
I want to say his name was Julian something, but I don't remember. But anyway, I was kind of like trying to figure out, like, could I use Rust for embedded programming, because, as we talked about with James in one of our very, very early episodes, sometimes testing for embedded systems can be kind of tricky, and I wondered if the type system in Rust would help remove the need for some of the testing that I would be normally inclined to do, and just sort of rely on the compiler and the type system to sort of solve those problems for me.
That's definitely so. Yeah, I would also pick Rust as like the next language I would sit down and learn. And I've touched it probably 6-7 years ago last, and I'd be interested to see how it goes. But for different reasons, because I want a language which is performant, but also has all the things you just talked about. Static typing, very strong typing, and I think that is also another sort of axis that one can slice.
Yes, definitely.
Languages down. We talked about like Lisp and Haskell and Prolog and C-like languages. They're all various different shapes of different parts of on the multi-dimensional space of languages. But some of the big axes are compiled versus interpreted, which we haven't yet talked about. Statically typed versus dynamically typed, which sometimes goes hand in hand with that compiled versus interpreted. And then how statically typed you are, right? In terms of, can you have full algebraic data types and things like that? And it is definitely like I spend most of my time these days writing C++, and it's not as strongly typed as, say, Rust in terms of the things that Rust is tracking in its type system, which is why I'm interested in seeing, hey, what would C++ look like if I could encode this information and the compiler can check it for me so that I just know it's correct by construction, right? If these things, if it compiles, then I haven't got any memory errors. That's really exciting to me. But then I spend most of my non-work time writing in JavaScript or Python.
Right.
Both of which are very, very much on the other end of things. And it's a really interesting trade-off, because there's no question. If you're going to write a little tool that's just, little shell script replacement tool, I'm going to reach for Python every time, because I can just get stuff done really, really quickly with it. And I don't need the rigor of the type systems. But, and in fact, that's probably not... it wouldn't matter if it broke anyway. I would get there and I'd be like, that's fine, that's okay. I'll have to rename a couple of files at the end of whatever I was trying to achieve.
Yeah.
And so there's definitely that sort of axis as well, where, like banging something out quickly. And I hear good things about Go in that respect, because Go has another sort of, so third, fourth axis, however many axes we're talking about now, is how easy is it to deploy the result of what you've done?
Yeah.
And that's I think Go brought that to the foreground for me when you start to see all the HashiCorp toys. They're not toys, tools coming out. Exactly.
Some people think they're toys, but
all the HashiCorp stuff, and it was all written in Go, and you got used to the idea of you download a binary and you chmod it and you run it, and that is the application. It's like, whoa, my mind's been blown. Where's the installer? Oh, there's no installer. It's just a 4-meg binary.
Just a binary, yeah.
Whoa, yeah.
Yeah, and Go is a language that I actually intentionally wouldn't put on a list of things to go and like learn on my own, because I'm expecting any day now
that you're going to need it.
That I'm just going to need it in my day job, and I'm like, okay, I'll learn it then, right? Like it's and maybe
you'll learn that on the company's dime, right, as opposed to your own personal dime.
And I mean, maybe I should warm up that cache a little bit, but Go doesn't also strike me as a language that's particularly difficult to learn. One person that I know that has written a fair amount of Go told me once that the way that you increase your productivity in Go is you type faster. There's not a lot of like magic
and that's
tricks.
The keyboard level of typing, not the type system typing.
Not type system faster.
And nor do you type the literal word faster. So just resolving ambiguities here.
Right. But yeah, it doesn't strike me as a language that's particularly difficult to learn. I think any language, it's there's always going to be a learning curve with the standard library and the library community and stuff like that. Some
like you
languages,
said, also the ethos behind it and the way that it's driven might not be against your personal flow. Like slices, I know are a big thing in Go, and I always stare at them and go, "What? Yeah, right, fine." Yeah. There's definitely that thing, and once that penny drops, you can usually make a lot of progress.
Yeah.
Sorry, I cut you off. You were saying something far more interesting.
Just that it doesn't seem like the learning curve with Go is mostly in the language. I would expect it to be mostly in the libraries, and that's the kind of thing that's going to be domain specific anyway, right? Like it's not like I'm going to go and survey the entire world of Go libraries and predict which one I'm going to need at my job to be able to do X and Y and Z that I don't even know what it is yet, right? Whereas another language, like, Haskell would fall in this category, Rust would fall in this category, the language itself and the environment itself has a lot of complexity to it. And independent of any particular problem that you would want to solve with it, from, a half mile away sort of staring at it, I think, there might be a lot of complexity there that just is just to get the hello world, or to do any sort of non-trivial problem, no matter what it is.
Yeah. Yeah, that makes sense. I mean, again, things like Haskell, I know, there's things that involve monads and things that nobody can explain or understand, and
it's like a burrito.
Things. It's like, don't start. Except a burrito you can't explain to anyone else without invoking other words. Was it an endofunctor in the category of monoids or something is what the definition of it is. Like, thank you. Now there's 3 more words I need to go and look up. But yeah, so some of those things do definitely fundamentally change the way you think about stuff. And so talking of something, and maybe this isn't a Haskell thing particularly, but in some of the other languages we've talked about, the idea of currying functions and partially applying functions and passing functions as first-class things, that to me is like that functional thing that really changes the way you think about problem solving. Because you're like, hey, I can do that I can compose these apparently arbitrary, distinct things and put them together in a way that can make some new thing without either of them having to change. It's all that solid open-close stuff. When a function itself is something you can manipulate and apply things to and make a new function in the language itself, that's a powerful construct, but it does require a lot of thinking, especially for an old assembly programmer like me. I'm not used to that kind of ability to change things. But
yeah. But I mean, the crazy thing about that, and I think a reason why it's cool to learn these languages, is like you can do that in JavaScript too, right?
Yeah.
So like, talk about something you use for your day job. It's like, you start thinking of designing programs that way because you have to, and then you start seeing places where you can, and then it's a question of whether you should. But but at least you know that you can, right?
Right. Yeah. So these things are applicable somewhere else. But I don't think out of the gate I would have ever considered writing. I mean, I guess newer JavaScript makes lambdas easier to write, but writing currying and composing other functions seems a little bit harder. I mean, although I think I've done some fairly disgusting things with eval and strings along the way. I think we all have crimes against the interpreter.
Yeah. Well, a question that I would love to get your take on is that there's obviously a whole bunch of different forces that feed into language popularity. What do you think it is that makes languages popular?
Yeah, that's a really difficult question. I mean, solving a need. And so actually, I was listening to another podcast the other day, the ADSP podcast, which is Algorithms Plus Data Structures Equals Programs. We'll try and remember to put a link somewhere in our transcripts. But in that, they were talking about this and saying there seems to be like sweet spots where certain languages that had very specific domains have been very popular in that domain. And by catering to a particular domain, they've become successful and have had a longevity. And so they were talking about things like Erlang, which is another whole different way. It's huge in the telecoms industry because it solves a very real need that they have for certain fault tolerance. And then one of the things that's brought up is, what about Python? The data science community has basically adopted Python as the and we're going to get hate mail from people who want us to talk about R, but Python is the de facto. In my mind, solution. But the thing is, Python's a general purpose language. It just happens to have a couple of really popular libraries, NumPy and Pandas, that do a whole bunch of useful things. And it's almost like a sub-community that have grabbed onto that more so than people using it more generally. Yeah.
I don't think Guido had scientific computing in mind when he made the language.
No, that's a kind of accident of how it turned out.
Yeah.
And then, things like C, I think, are very... They found a sweet spot above assembly code and below anything too complicated, so that it got a footholder in the early days of Unix machines, and it became like essentially the way you talked to the computer in a reasonable way. So maybe that was it. Now, C++, on the other hand, I don't know why it's been so successful. Everyone complains about it, but Bjarne is on record of saying there are two types of programming languages: the ones people complain about and the ones people don't use. Mm-hmm. And I think that's a fairly good and reasonable thing to say.
Yes,
so
yes. Well, we were talking about this the other day. I think is maybe a kind of an interview question when you're talking to somebody that says that they're an expert in one language or another, and it's like, oh, okay, well, give me the top 5 things you hate about it, right? Because if you can't list that, then you haven't been using it for long enough to really call yourself an expert.
Wow, that's a good question. Well, it's a question. I don't know what I would say about that. If you ask me what are the 5 things I hate about C++, I'd be like only 5, and I wouldn't have enough time to winnow it down. But no, that's an interesting one. So in terms of longevity, I don't know. I mean, one language I'm just thinking out loud here, which is while I was thinking of languages that have been successful and are still doing well now. Java. We haven't spoken about that at all, and that's a very interesting one. That's sort of perceived to be very enterprisey. Certainly it was its sort of first forte, although my understanding is it was originally written so that small-ish embedded devices could,
absolutely.
could toaster, Java on your toaster, and then you didn't have to retarget it for some other
one of my first side projects out of school was building J2ME, Java 2 Mobile Edition apps for a Nokia stick phone.
Wow.
And that was a fun little project right there. Did you ever do anything like that with
I
J2ME?
did. Oh my golly, J2ME, the original OG YouTube app Google was J2ME for some of the devices that only supported it. And that was, you can imagine, the perfect confluence of not really Java.
Yeah.
Also, not really powerful CPU, and certainly not very standardized MJPEG decoding hardware. And, that's a holy trinity of pain and suffering. And so, you'd be like, I got it to work, except that the red is green and the green is blue. And I can't change that because it's just the one and only thing I can do. So,
oh man,
maybe we should just transpose all of the videos on YouTube and switch red and green around.
And somehow that turned into enterprise server lit something.
Right. I mean, we all everyone's got their favorite way of taking the mickey out of a language, but Java's one is that you put get factory setter interface something or which is not strictly fair, and especially I like to point out to a lot of people, especially from say the C++ community, who like to hate on that kind of thing, or hate is too strong, but take the mickey out of, is that unlike our compilers in C++ world, although Java is compiled, it is also JIT compiled as a second time. So we know that it works, we got bytecode, and then we're like, hey, all those layers of software in direction, and the factory getter and all that kind of stuff. Hey, we compiled that out dynamically at runtime. We were able to determine that none of these things mattered, and it's just like get 12. Yeah, and C++ can't do that yet, so we shouldn't be, too writing off of.
Yeah, the
Java.
JVM is one of the most amazing pieces of technology ever. It just, I use Java a lot. I used a lot of Clojure. I used a lot of other JVM languages.
I've forgotten that Clojure actually backed onto Java as a
right.
target.
And underneath the covers, it's all the same thing. And the cool part about that is that if you spent a good chunk of your career understanding how the Java garbage collector works, that translates pretty well into pretty much any other J2ME language. You use the same set of tools.
Not J2ME, hopefully.
What did I say?
You said J2ME again. I'm like, oh gosh, it's stuck in your head. Yeah, any other JVM language.
JVM.
Let it go, Ben.
Yeah, it's post-traumatic stress disorder from the from the early days. Use the same set of tools. The same sort of foundational principles of what kind of problems you run into and how you troubleshoot them and what you're looking for are there. Obviously, the ways that you deal with them might vary from language to language, but it's kind of a cool ecosystem to live in, really.
Yeah. There's a lot of fungible knowledge, which is a good thing to have. Right?
Yeah. Plus, being able to reuse the libraries across them all is an amazing thing, right?
Of course. The interoperability story is also there.
Right. It's only if we had an amazing text processing library. Oh, you have Lucene. It's been here for 15 years. You can use it in any of these languages. It's great.
Yeah.
So whatever it is, it's kind of cool.
And of course, it also spawned the Android apps are all Java through some crazy transcodey something Dalvik something lawsuit. I don't really understand how that ended up, but that was the thing at the time. So obviously that was seen as being the best a good solution for it. And so it's done really well. And C#, while we're here talking about languages that broadly fit, I see so much for any kind of plan that we had about this, in as much as we ever have plans for these chats, but we're meandering all over the place, and hopefully our listeners
just like programming languages do, right?
Well, that's true. But C#, I really enjoyed working in C#. In fact, I rediscovered some C# code that I'd written a long time ago for a game for Xbox. What was it called? There was some kind of like community-driven Xbox thing. You could make games for your Xbox way back when. It was an experiment that Microsoft canned fairly soon after, unfortunately. But that was pretty great. It wasn't perfect. Something garbage collector. Couldn't do anything with it. But that's more to do with the runtime than it was the language. I really liked the language, and one thing that it had over Java, which I think has been rectified now, although I'm sure someone will tell us if it's not the case, but is it like allowed you to have actual value types, like structure types that are values, like, hey, this is an X and a Y, and I want you to pass it around as a copy of the X and the Y, which are just 4 bytes each, as opposed to everything's an object, where Java will hand you, like, yeah, sure, you want a new one of those? Here's a new one of those. And I'm like, no, don't put it on the heap and give me a pointer to it. I don't want reference-like semantics. That's actually not performant, and also doesn't have the semantics that I want. And so maybe there's another axis of our world is, value types or the ability to have value types or reference. I mean,
all these things are just kind of like language features. Like, as much as we think of typing as this like really definitional thing, it's kind of just like a language feature. Now, it is a pretty significant one, but at the end of the day, any of these things just comes down to the way the languages are designed. I may have mentioned this before, but I do have this theory that a lot of problems that get held up as really important problems actually just come from language design. Because when you think about, like, oh, what should we put in the standard library? It's like, well, I have these problems as the designer of the language, so maybe other people do. I'll put them in there too.
That's interesting.
And sometimes those are problems that other people have, but a lot of times I feel like things kind of sneak into the language itself or sneak into the standard library are the things that are much more narrow in scope than the people who create them think they are.
I mean, to some extent, sometimes the syntax of, if we're going to get to the sort of like the nuts and bolts of languages, like the actual things you type can force you to in one way or another. So, for the longest time in JavaScript, you could write anonymous functions and then you could pass them as callbacks and everything and whatever. And it was a pain because you write function, open paren, close paren. And then, the Lambda syntax came along and it's exactly the same thing. But now I don't think twice about writing a little Lambda that lives inside something and we pass it in. Yep. And the things that are easy to do, I mean, we all know how lazy programmers are, which is a good thing, right? If we haven't already said that...
One of the 3 virtues from Larry Wall, right?
Yeah, right. There you go. It's laziness.
Laziness, or hubris, and I don't remember. Memory, probably.
Yeah, right. But the syntax. If something's easy to type and it's everywhere, then you will use it more. I mean, it goes without saying, really.
Yeah.
In C++, similarly, for the longest time, you could define little static functions and then pass them into other functions as like the address of the other function over there. But when they came up with the Lambda syntax for that was, another eye-opener. Suddenly you're like, hey, I want to make a callback. Oh, I can just give it a callback and make it in line. And suddenly that opens the door. And now you're thinking, this design doesn't suck now because it's easy to do. I'm handing people things that don't feel like it's difficult now. Because it's C++, there's 100 reasons why it's pretty difficult to do that well. But I wonder what else falls into that category. I know that, again, from ADSP that I was listening to, APL, which is like a very old programming language, uses symbols exclusively for all of the things. And there's thousands of different ways you can have infix and outfix operators and stuff. And that means that you can have a very rich, if terse, language that sort of combines things together in a way that, like, I don't think I would necessarily like, but maybe that I'm missing something here. I mean, there was things like, having the pictograms that mean different things are actually help you understand what the algorithm does better than maybe the name does. It's like a pictorial representative of like rotation or extraction. So like in pandas you do, what is the thing that you call stacking and unstacking, and they're like these little things that mean that, and I'm like, I think I could see that. So that's another thing, and again, without wishing to completely sideline us, but that's what this podcast is. Like everyone's podcast is so. In human language, there's a theory called the Sapir-Whorf hypothesis. I don't know if you've ever heard of this.
I think I have heard of this.
Right.
Yeah.
Yeah. Do you want what? Yeah. You.
My memory of this is that your the way that you think about the world is limited by your language, right? So if you don't have words in the language that you speak, then you have a much more difficult time thinking about concepts that don't fit that language.
Right. I think to an extent that my understanding, and again, we're armchair folks just discussing things we remember from reading in books sometime, but certainly the first language that you learn, like your mother tongue, fundamentally changes the way that you think about the world, is what that hypothesis was, which is a very difficult hypothesis to test. Because you're like, but there are languages. So some of the sort of theories behind the languages, that there are languages for which there are essentially tenses on words that describe whether or not you know this as fact, whether you heard it from someone or it is generally known. So if you imagine every time I talk to you, there's a different ending on the word. If it happened to me and I'm telling you it's truth, or a friend of mine told me, or they say,
right.
And
it is known.
You can't help but feel that would fundamentally change the way you process information if you're essentially in your own head having to tag all information as being from one of these three categories.
Super useful, actually.
Doesn't it? I mean, especially in today's misinformation soup that we live in.
I would love to have that.
So it seems plausible, right? Certainly the hypothesis seems plausible. And I wonder if the same is true, or a sort of more generalized version of it is true about programming languages too, right?
Yeah.
I mean, to the extent that we just said, hey, learn a new programming language, it expands your mind. Maybe you'll think of new concepts that you can apply back into it. Obviously, that's us trying to take our intuitive understanding that that's true and reversing it and going, well, how can I become better as a programmer? I know, I'll take advantage of this and I'll learn another language and I'll expand my mind further. But I wonder if the actual root thing is also true. Like the fact that the first thing you learn shapes the way you think about computers, because while it's not the exact first thing I learned, the very second thing I learned very shortly after the first thing was 6502 or Z80 assembly.
Yeah.
And now I think of everything through the lens of an 8-bit computer, and I can't help but feel that still happens to me at some level.
Yeah. No, that probably is.
It seems like that, and obviously the folks who are coming in now who haven't been exposed to that kind of stuff are coming in at a different level. Maybe their first language was Java, right? A lot of people that were graduating, certainly 10 years ago when I was actively involved in recruitment more, were Java. They were like their universities were only teaching Java, and that taught them to think about the world a certain way. That's not bad or otherwise. It's just different. And I wonder what people learn these days, whether it's still Java or whether And I know that some universities do target C++, so I know that
there are
we
still
have
some
specifically targeted those. But I wonder what else there is. Is Rust being taught anywhere? Are any of these languages being taught well? Which is the other thing, right?
I have spent my last week doing nothing but reading resumes because it's August and it's campus recruiting time.
Of course.
And most of the things that I see are Java or C++. There's some Python in there.
Interesting.
And what I have seen, I think, a lot is it's not one language for the entire degree. Right. You'll have classes that are taught in particular. And that was true when I was in school too, right? Like, the selection of languages was a little smaller, but most of my core programming classes were in C++, but, we had classes that were in COBOL. We had classes that were in, there was at least one class that was still in Pascal, even though they had switched over the core program to C++. But
COBOL.
Yeah, the databases class was in COBOL.
Tell me how old you are without telling me how old you are.
Yeah. No, that's true. But yeah, I think that's definitely a thing. And there's also kind of an interesting intersection of these 2 points, which is that almost all, maybe all, I actually don't know, programming languages, the keywords are in English. And so if you're a native English speaker, you have a particular meaning in your head for those words that, maybe is close to what their intention is in the language itself. But if you're not a native speaker, then this is just a word, right? Like you
Yeah.
have your own concept of that's maybe separate from the language, right?
Yeah, that's a very good point. Definitely the case that with most languages, if not all languages that certainly all languages I'm aware of, but
I don't know any that aren't.
Most programming languages that I've heard of, and again, I've heard folks discuss about various programming languages with this question, have said, no, they all end up being mostly Anglo-centric of some description, which is an interesting, and that was actually where then the APL being all symbol-based was an interesting counterpoint. So... yeah, maybe the names. I mean, naming is we could do a whole other episode on naming.
Oh, yeah.
We could probably do a whole podcast on naming because naming is really difficult.
Yeah.
Really, really difficult. But getting it right is so satisfying, right? That's like when you find that word and you're like, yeah, this is what I mean. So let me give you an example. So I'm going to tangent on the tangent on the tangent. So we're probably back where we started. Or one more tangent and we're back where we started, I think. Yeah. We were trying to deal with a piece of code that had sort of two timelines. There was the wall clock time of the computer itself, and then there was the time that essentially simulation time. Mm-hmm. And we were very excited when we found the word juncture and we gave it the meaning of this is the simulation time, right? At this juncture, we were doing this thing, right? It's a very posh sort of barking array in the background. It's a very sort of posh way of saying time, but so we gave it new meaning. So I guess that's also not a great thing, but it was something we all understood was like, if you see a juncture time, then that is not a wall clock time. That is a time that you think that sometimes they coincide, right? But quite often not. Right.
Yeah.
And it was an interesting thing. And then to go back to typing, making your juncture type, essentially it's still a 64-bit number. That's how many nanoseconds since 1970 or whatever, but having it a very different static type from the wall clock time type means that you can never mix them up.
Yep.
And that's a super important thing in, I don't know, trading systems, just picking a random example out of my posterior. Mm-hmm. So I know we didn't ask about why one might want one versus the other, but that was that. There we are. So
yeah, no, and it's funny how different languages will inform the way that you pick names in different ways, and a lot of times it's the community behind the languages that is doing that. Obviously, as I already talked about earlier, the pattern in Java for a very long time has generally been to be extremely verbose and throw all of the whole soup of nouns into the names of your classes and functions. Yep. And I think that was maybe a reaction to some of the earlier stuff where you would have variable names like C and R and C underscore R.
Right, because it goes faster if you use shorter names because the computer doesn't have to look up as many characters, obviously.
Right. The compiler goes so much faster when you do it that way.
Yeah, that's why you should use tabs and not spaces as well to indent, because it's fewer bytes to go through.
Fewer bytes to get through the parser, right.
Yeah.
So yeah, it's all this. It's amazing all of the different effects that all of these things have. I'm probably sure that most of them were not intentional, but they
absolutely I mean, some things have sat down intentionally and said, no, this is how we're going to do things. All the getters and setters in Java are almost forced to be that because of sort of things like Java beans.
Java beans. Yep.
That sort of said that, and that's a powerful thing to say. Okay, that's how we're just going to set and retrieve things, and now. Tooling can come in and use that to its advantage. So there's definitely something to be said for that. But do you need to put get in front of things? I don't think you necessarily do. Maybe setting. Sorry, my dog is making all the noise again in the background. We've done so well recently with noise from dog, but he's discovered plastic. His favorite toy in the world is a plastic bucket, such as a child would use to make sandcastles with. Okay. And he has chewed that to death. And now he's knocking it around in the background. So apologies for the background noise. So I guess where does that leave us? What choices does one make? So I do like usually the performance of a language is important to me, unless it's a script thing like I discussed. And to be honest, actually, if you're going to write something in JavaScript, it's amazing how fast things can go in JavaScript these days.
That's crazy.
So that's an impressive achievement there. And you've got TypeScript, which kind of can give you a certain amount of types on top of JavaScript, so you can kind of recover some of the other things that I like, which is as much as possible make it so that if I've got bad code that won't work, the compiler tells me before I have to run my tests even. So that's my own choice there. And obviously there's a huge continuum between fully dynamic and test all the things and fully static check all the things, and you don't need to write tests because your code, if it compiles, it works. That's a nice property to have.
Right. Yeah, no, I definitely fall very much on a spectrum when it comes to those kinds of things. The main thing for me is just making sure that it's easy to get to a point where I'm confident that my code works. And I'm perfectly happy to write fast focus unit tests to get there. I'm happy to let the type system do it if it'll do it. The thing that drives me nuts is when the type system tells me that I need to do a thing that doesn't actually give me any confidence, and I have to write the tests anyway, and then the tests are hard because the type system gets in the way.
Got it. Are you referring to Python, for example, in this instance, or not?
I'm not referring to any particular language. I have felt that pain in many, many, many different languages.
Got it.
I
know recently we've been... Some of the stuff that we've seen at work is Python, and there's people like me who are like, I really, really, really wish Python was statically typed, so I'm going to put every single type hint known to mankind everywhere and try and pretend like that's actually doing anything. For those who don't know Python very well, it is literally a hint. It's possible to
it's like a
read
comment,
the hints off, but nothing.
Yeah,
it's a comment, but in principle, it's a comment that can be checked by a checker. But for various reasons, we're not checking as much as we ought to be checking, so we're not getting the benefit of it being all nicely typed. So you've kind of got the worst of all worlds. You've got IDEs that are giving you red squigglies because you type hinted it, and someone else is passing in something which is basically the same, but not the actual same type. And it kind of. You squint, it comes out in the wash. It's like, yeah, it's fine. It's got a getter and a setter. That's all I needed.
Right.
But it's not. It doesn't derive from get settable or whatever you've decided your type is called. And you're like, nah. Which actually comes back to Go and my grief. Sorry, we should definitely stop soon because I'm just going all over the place here. But the thing I found interesting about Go is that it has structural typing rather than nominative typing. And I think I'm getting that the right way around. So you can say, my class needs to be passed something which has this interface, and the interface is, set foo and get foo. Those are my two things that interface has. And at no point do you need to, in your thing that implements that, say that that's what you're doing. As long as you have those two functions, get foo and set foo, then you honor the contract of foo settable.
Interesting.
And that's interesting. If you have, to me, that's really interesting because it allows you to post hoc layer on interfaces where none existed before. Like, I can take someone else's code and sort of, again, open-close principle, say, hey, look, you've got this thing. I now can retrospectively put an interface over you, as long as that interface has your as long as you implement the methods that are in your interface, and now I can pass you around as this interface to other people.
Oh.
Without having to shim anything myself, right? Because you implicitly are one of these.
So you're not declaring something. It's just looking at the usage of it from within, like, the function and saying, like, oh, this variable must have these methods.
What it's doing is when you pass an object as like a concrete type as an interface, it just looks at the methods that you have in your object in your concrete class and compares them to the interface. And if they match, it's like, hey,
I get it. Yeah. So there's no inheritance mixed up in that at all.
Exactly right. Yes, and there's no implements that you have to write, which is to say, means that you can layer them on afterwards, which is cool. But I don't like it. I don't like it because I think it should be very intentional. If you are choosing, like, I'm an implementer of a class, and I'm choosing to be loggable, right? Because I have a log method, and my log method does a logging, right? Does right. And now, if someone comes along and and this is extremely, I'm just being silly to prove a point. What if you now have math loggable, which means, like, hey, this is the logarithm, the natural logarithm of a number. And you're like, hey, I can pass in my logger into my freaking log, my math function because it implements log. And you're like, no. I mean, obviously that's just the name, and obviously the parameters would be different, or whatever. But, like, there's a very big difference between that. And I had a much better example at one stage where, like, the intention of something is very different depending on what the interface is, as opposed to the name of the methods. The methods are ambiguous without the context of, well, is this, what is this doing here? Is this if I had it at the top of my tongue now, I would tell it, and now I just sound silly, but never mind. When has that ever stopped us? Thankfully.
Never once before.
Never have we stopped.
Never once before.
Well, this is obviously a gigantic topic, and I know we've got some cursory notes, and we've barely scratched any of these things. And but we could definitely go over some other things another time. I'd be interested in knowing what our listener thinks of various languages and what makes what goes into the choices folks use for both their home projects, such if they have them, or like little throwaway projects versus like big. This is going to be supported for 2 or 3 years in a company kind of context. And whether there's something we're missing, because I'd love to hear. So tweet at us.
Absolutely. Yeah, this has been a good talk. I think this is a good place to stop. I'm a little disappointed that we didn't get to talk about the most popular language that's used in programming, though.
Oh.
Profanity.
Oh, profanity. All right, yeah, well, I was close there. Yeah, cool. It's always fun to git grep and find out how many times someone has checked something in.
Yeah, right.
Well, cool. Until next time, my friend.
Until next time.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbold. Find the show transcript and notes at twoscomplement.org. Contact us on Twitter at 2CP, that's at TWOSCP. Theme music by Inverse Phase, inversephase.com.